Welcome to our SplashLink webinar series. I'm Emily. I'm the Communications Coordinator here at SplashLink. I'd like to tell you a little bit about ourselves. We are the first online marketplace to support connection across an entire range of project, financing, sourcing, and market intelligence needs for the highly fragmented and increasingly stressed global water industry. Whether dealing with industrial process water, municipal infrastructure, or drought adaptation, SplashLink accelerates response to local and global water challenges by connecting industry players and opportunities like never before. Today, our speaker is Ebie Holst. In addition to being our founder and CEO, Ebie has been focused on water-related market trends and technologies since 2009, identifying key water-related challenges, commercial assets, and innovation opportunities relevant to markets around the world. A Price Waterhouse and 12-year Silicon Valley veteran in information technology, as well as a seasoned consultant and navigator of the startup landscape. Ebie has worked in both information and clean technology and brings over 30 years of management and practical experience in the strategic design and launch of new business models and alliance initiatives across multiple sectors and more than a dozen global industries. Within the water industry, Ebie has been tapped as an advisor and speaker by organizations including the White House, Brown, Gibbons, Lang & Company, and numerous industry associations and clusters, as well as water-intensive industry stakeholders such as oil and gas. Ebie serves on the Environmental Technologies Trade Advisory Committee for the U.S. Department of Commerce on global markets for water and wastewater technologies and is a graduate of the University of Michigan. Our topic today is going to be why smart water and why now. Ebie?
Thanks, Emily. I'm really excited to cover this topic with our listeners today because it's a very timely topic. It's something that is really starting to emerge here in the United States. We're not quite as advanced on smart water as we've seen in other parts of the world, but we'll talk a little bit about that. But before we do, let's talk a little bit about what we mean by smart water. We actually use the definition that's in place from the Smart Water Networks Forum based in the UK, a global organization, a partner of ours. And what we mean by smart water is the use of digital tools such as sensors and electronic devices, the transmission of digital data, the management of that digital data for decision support or automation. And that can be really almost anywhere within the natural environment to track water quality, for example, within the natural environment, or to track pressure, volumes, flows within an actual water system or water infrastructure. Smart water technologies, also known as digital water technologies, are becoming increasingly prevalent within smart city initiatives. So smart city initiatives, for any of you that are aware of that term, generally refers to urban areas, urban planning that employs a range of devices to more efficiently optimize how a city works. It could be smart street lights, it could be smart water-related things, it could be a whole range of different things around infrastructure. And smart water is becoming a part of those initiatives in regions all over the world. So as I mentioned, the way that smart water networks can be used and the various devices that make up a smart water network can be used to track volume and flow and pressure of actual water assets as they're passing through an infrastructure. The ability to do that is not new. It's just that historically the mechanisms that track those things have been more mechanical than digital. The digital aspect of this actually enables a more real-time read of the information that's coming into the system rather than requiring, for example, someone to go to a specific location to get a reading of that information. Increasingly, we're also seeing smart water networks provide support to tracking chemical and contaminant levels. This is a little bit newer area, so if you have sensors in place to track a specific contaminant, generally speaking, so far in 2018, those sensors have to be designed for tracking a very specific contaminant. So a sensor that can detect mercury, for example, in water is not necessarily going to be the same sensor that can detect a toxin from algae, for example. So there's a lot of innovation ahead on that front, and it'll be interesting to watch. At the same time, we're seeing smart water playing an increasingly large role around detecting leaks and potential failures in infrastructure. So in some parts of the country where there are water drought or scarcity conditions, this is where we're seeing some pretty aggressive adoption in the use of smart technologies to help prevent those leaks, because obviously conservation is a priority. In addition, tracking customer usage is oftentimes one of the entry points that we see from buyers around smart water technologies. In different parts of the country, the reasons for this really vary. So, for example, in the scarcity-prone regions, water scarcity-prone regions, again, it's about water conservation that is the driving agenda for adopting automated metering, for example. But in other parts of the country where scarcity is not as big an issue, it in fact turns out to be something that's driven by overhead concerns. So, any of us that are over 30 years old have probably a lot of memories around having a meter reader coming to the house and checking the back of the house to get a reading on how much water's been used, and because sometimes that's pretty labor intensive and has some safety issues associated with it, there's estimated billing that goes with it. Well, we have a more digitally savvy consumer base out there for water services, and they're looking for more real-time information. And at the same time, utilities are trying to keep their overhead down and aren't necessarily able to provide as large a workforce as that's required in the past. So fundamentally, the reason players are interested in smart water, increasingly so over time, is the ability to get that real-time information and even predictive information with regard to source water and water infrastructure and systems. And this real-time snapshot means that a utility or community or even an industrial player has the ability to adapt very quickly to a change in any of those conditions, but also over time to see trends and plan ahead and even collaborate with other utilities and players that are dealing with similar conditions. So let's talk about the essential levels of a smart water network. Again, we're using the definitions here from the Smart Water Networks Forum, SWAN. And based on their definition, the baseline of the 5 levels starts with the physical layer. So that means what's actually happening out there in the world without any additional devices in place. What's happening in one of the Great Lakes by its, just its very nature of everyday conditions, also to the infrastructure that might be in place and has been in place for 50 years when it comes to water distribution, for example. That physical layer is incremented then in the adoption of a smart water network with sensing and control technology. So I referenced a little bit earlier the deployment of sensors to detect specific conditions, as well as the use of digital technologies to potentially automate or control some basic changing condition within that physical layer. Once those types of digital mechanisms are in place, it doesn't have a lot of meaning, though, unless the information that's being sensed or collected is actually going somewhere. So we'll often hear about the transmission of data from sensors, for example. The transmission of that data can occur, for example, through internet mechanisms or through radio frequencies, and then collected in some place based on what it is that's important to the user to capture. Again, once that information is communicated, it still doesn't really have meaning until you're able to show the data. And so we're seeing players that are in the smart water space, working within any one of these different areas, including connection of this kind of data into existing SCADA systems. And then finally, the ability to derive meaning from the data. So rather than just a direct stream of, here's the conditions at 3 o'clock, here's the conditions that we've been detecting at, 3:05, the ability to actually take that information that's being streamed and turn it into, this collection of data points actually translates to a potential contamination or a potential infrastructure failure. So with the research that we've been putting together, we've actually focused on that very fundamental level of an actual network, which is number 2, the sensing and control, as an indicator of smart water adoption, because these are the mechanisms that need to be in place for any of the rest of that smart water network to function. So let's talk for a minute about the catalyst for adopting smart water. I've mentioned a couple of these along the way so far, but aging infrastructure is certainly one of the biggest catalysts. We are seeing across the United States the kind of confluence of a number of different factors that are causing infrastructure failures. We literally have pipes under our streets in parts of this country that include wood pipes, and we also have a range of other materials that are connected into these systems that are also coming to the end of their life cycle for warranted usability, certainly, but more importantly for actual usability, where we're starting to see breakdowns and changing water conditions, changing weather conditions causing water main breaks and so forth, in part because of how old some of this infrastructure is. The projected cost for repairs and upgrades is massive, and it's also the type of figure that not only would strain any budget within communities and utilities anywhere in the country, but also is just practical, it's not practical to pursue. Anytime you're going to replace a pipe, for example, under the street, that means tearing up the street. It's, can translate to a loss of business, commerce. It's very disruptive to traffic patterns and so forth, certainly in more urban areas. And so with those projected costs for repairs and upgrades, the interest in smart water is to really utilize technology to identify where the priority areas are. Resurging concerns over water quality. Now, there are a number of things that are playing into this. Some of it has to do with some industrial types of activities. We've certainly seen that in the U.S., 30 or 40 years ago, and there's some resurgence of that. But we're also seeing water quality concerns as they relate to runoff into source water. So, algae concerns, overall nutrient runoff. We also tend to see, where there are drought conditions, higher concentration of potential contaminants in smaller volumes of water overall, and this all feeds into an interest of being able to detect contaminants before they have an impact on drinking water in particular. Another driver is that the factor I mentioned a little bit earlier, which is increasing demands for billing and communications. We as I said, have a more savvy consumer base out there, and there's, you know, as a result, more interest in having accurate information that's at their fingertips, and certainly for populations that are vulnerable to potentially higher billing rates for their water and drought areas of water-scarce areas, there's a lot of interest in being able to track and manage your own behavior relative to water, and that's driving some of the adoption. And again, rising needs for operating efficiencies. I mentioned this in, you know, for example, in the Midwest, there is a real need to be responsive to tighter budgets. But overall, just to put this in perspective, federal dollars available for water utilities and communities around water has been decreasing for, you know, a couple of decades now. And so it really is an era of how do we do more with less, and using smart water technologies can really help to solve at least part of that question. So let's talk a little bit about adoption outside of the U.S. I mentioned at the beginning of this presentation that we have, in the U.S., a little bit slower rate of adoption than we've seen in other parts of the world, and there are a couple of reasons for this as well. One is that in the U.S., there generally is not a set-aside of municipal and utility budgets for innovations. Other parts of the world actually have that as part of the budget protocols, that a certain amount of the budget is put towards the use of new technologies or new approaches for managing water. Not so much here in the U.S. The other thing also is that we have, we talk about a very fragmented industry all over the world for water, but in the U.S. certainly that's true. There's more than 55,000 public water systems here in the U.S., and having a good grasp of where to spend that money and how to communicate what works and doesn't work is challenged as a result. Amongst those regions that are actually in the earlier adopter large project segment are the Asia Pacific for one. So for example, Australia has been putting in a pretty wide range of smart water systems, not only in the public sector, but also within their schools, within shopping centers, within a range of private sector businesses and commercial interests well beyond the public sector and utility space. Outside of Australia, which of course is in part driven by those scarcity and drought conditions that Australia tends to see, we're seeing a lot from China. China has been one of the biggest global investors in new water infrastructure, and as a result of that, are really including smart water technologies and networks in their infrastructure from the very first build. On the Chinese island of Taiwan specifically, one state-owned water utility serves nearly 18 million customers, has actually announced plans to deploy an Internet of Things or IoT cloud-based data analytics program to monitor and manage over 1,900 mile sections of pipelines within its supply network. China alone, outside of that, is expected to nearly double its smart metering initiatives between 2016 and 2021. So there's a lot going on. I mean, even smaller Asia-Pacific countries such as Singapore has more than 320 water quality, pressure, and flow rate sensors throughout its potable water supply, and the list goes on and on. In the Middle East, we see a couple of significant players here. In particular, Saudi Arabia has been one of the early adopters and kind of longest users of desalination-related technologies. This makes a lot of sense. Very dry region of the world, started to put a lot of money into desalination technologies, and over time, because it's historically been such a energy-intensive way to process water, there's been a lot of interest that's shifted into water reuse and recycling. But that also means that there's been an interest in being able to detect contaminants, obviously, in the water that they have spent so much money creating, and also in leak detection technologies. Israel is another player in the Middle East that fundamentally is one of the leaders in the smart water space. Smart irrigation is one of the leading technology providers around this and innovators around this, as well as a range of other water scarcity related technologies, which also have spawned a real growth in smart water networks and devices. In Europe, I was surprised to learn that, in fact, Ireland is one of the bigger adopters around smart water. Ireland has about 80% of the country's population being served by one national water utility, and they have installed more than 1 million smart water meters since mid-2013, and have since put in a very wide-reaching SCADA system to access real-time data from remote terminal units, or RTUs, in nearly 300 different locations throughout the country. The Netherlands, as well as the United Kingdom, are also some of the early adopters or aggressive adopters around smart metering. The Netherlands, for example, having deployed 100,000 plus AMI-enabled volumetric water meters just in 2014, and they're continuing to evolve that network. The most notable player in Africa is actually South Africa, and this may not be a surprise to anybody listening. We've been hearing stories about South Africa and the extreme water availability challenges that they've been navigating with their population. And in addition to that, we're also seeing in Central and South America, a pretty surprisingly aggressive adoption of smart water technologies, as well as of grouping together multiple countries to try to procure larger scale funding around the adoption of smart water technology. So, for example, Brazil, as we've heard over the last several years, has been navigating extreme drought conditions and has been looking to leak and sensor contaminant detection. And Chile also has rolled out an Internet of Things cloud-based event management system to over 2 million consumers to improve water conservation and reduce water bills. In 2014 through 2018, a grouping of Mexico, Brazil, Uruguay, and Argentina have pulled together to pursue smart city initiatives, and as of 2017, 80 municipalities across Central and South America were actively pursuing a combined $9.5 billion in funding for water management projects. So a lot going on outside of the U.S. In the United States, there have been, I mentioned a couple of the challenges that we've, utilities and communities, for example, are navigating to try to adopt smart technologies within their infrastructure. Among the additional considerations is just general education and familiarity with smart water uses. And you know, I think that this is an issue that continues to be somewhat pervasive, but we're overcoming. You know, one of the things I said at the very beginning of this webinar is that the buzz is now kind of starting to really spread across the country. Certainly there are parts of the U.S. that are moving more quickly around this where there's particular stress. But the ability to get insights amongst the peers of utilities of what have you used this technology for, why did you do it, what are the benefits you've actually been seeing is has been historically a challenge and something that I think we're going to see evolve over time. The next is the cost of initial investment. So again, without the education of this described in this first bullet here, the cost of initial investment can be perceived as very high without having a sense of what the return on investment might be or the benefits might be, particularly amidst some of the day-to-day types of challenges that these utilities and municipalities are trying to prioritize, right? So if we've had 5 water main leaks, water main breaks over the last 18 months, then the focus is going to, by default, be on fixing the water main and not necessarily on putting in incremental technologies that might help them prevent the next challenge. Proving the technology, and this is also tied into cost of initial investment, but you know, as familiarity grows, since this is still a somewhat young sub-segment of the water industry, smart water networks and technologies, proving that technology is still a perceived need, and that initial cost, any of you that are looking to bring new technologies in the smart water space to market need to bear in mind that in the eyes of that customer, you are not just the cost of putting your technology in place. It's the cost for them of having a system run in parallel with what they've always done, because they need to see for themselves how your new technology is performing relative to the way they've always done it, or how the information your technology is feeding them it compares to the information they've always been making decisions on in their more traditional ways. And then there's staff training and learning curves. Now, some of this is, in fact, going to be linked to the industry having, you know, a somewhat older workforce. We've got younger folks that are coming into the industry, not necessarily very quickly, but there is a sense of not only having that comfort and familiarity with more digital tools, but also the nuances of the digital tools that are coming to bear, and the fact that there are still some standards around that have yet to evolve. And then overall access to funding. So, you know, historically, making repairs or upgrades to infrastructure have historically been paid for by the use of raising fees on customers or putting a bond issue in place. There are, in fact, a whole range of alternate ways to pay for these types of things. But this, again, is something that needs more visibility. And in turn, we have some of the utilities or communities we see that are putting in place, for example, smart metering with their residential customers, are finding ways to include that in the charges to their customers without necessarily having a whole lot of pain as a result. So let me tell you a little bit about SplashLink relative to this kind of information, this data that we're sharing with you about what we're seeing. You know, we have this platform. We host a range of transactions within the industry. You know, we have tens and tens of thousands of bids and projects and requests, as well as funding opportunities, some $10 billion of undeployed funding for the water industry that goes through our site. And that means that we can actually see what's happening based on behavior within the marketplace. So, this is a little bit different than you might see with other types of market intelligence reports. Most of them out there are based on surveys. We surveyed some 50 CEOs and asked them where they expect to be spending their money over the next few years and why, and that's invaluable insight. But it also is, it's very qualitative, projected insight. It's based on people's opinions, and what we bring to that party is the ability to say, you said that you were expecting to spend this amount of money, and based on the behavior, here's what actually happens. That's what SplashLink does when it comes to market intelligence. So, with some of our analysis within our Smart Water series, launched here in 2018, was to really look across the last 3 years, 2015 through the end of 2017, across the U.S., what we were seeing within different regions of the United States based on their behavior of smart water adoption, indicators of smart water adoption. And as you can see here, the South is really the highest adopter that we were seeing in that 3-year period. Midwest, for example, we saw growth year over year in the Midwest over the last 3 years. There are different things that are driving adoption, as I mentioned earlier, of smart water technologies. The West, again, for the most part, really focused on water conservation with some of the scarcity issues that have been in place. Southwest, similarly, some of the water scarcity issues, but also flooding. Both the Southwest and the South have dealt with some pretty extreme storm conditions, and they're looking for more resilient infrastructures and so forth. So some pretty interesting things going on there, and across the same spread, some of the things that SplashLink has been looking into is where is there money available to pay for some of the smart water opportunities that are out there, and some of that money can come from not only research and development types of sources, but it can also include things like watershed protection. So, for example, if you have a number of foundations that are interested in funding initiatives that provide watershed protection of XYZ area, that money can be, in fact, put towards the adoption of smart water technologies to prevent, sewer system breakdowns and so forth, because that, in turn, really does protect the watershed. So there's some indicators of rising interest. We did some evaluation around increasing M&A activities. This is a really interesting time for some of the newer technologies that are coming out in smart water, because some of the giants within the water industry are very interested and aggressively pursuing potential partnerships and or mergers and acquisitions with players that are providing some new valuable technologies out there around smart water. There's growing visibility and investment. So certainly the venture capital world that is interested in water has a lot of interest in the smart water network area. It's something that, from an investor's point of view, doesn't have the regulations that we see in other types of water technology. You don't have to have a certain piece of equipment that's going to be touching drinking water that has to meet certain regulatory standards. Smart water is a data play, and so it's seen as an easier path to invest in and get some return. And of course, we're seeing more and more public-private partnerships discussing and talking about the opportunities of smart water, for example, through some of the water clusters in the South and in the Midwest, as well as internationally, like with SWAN, as we've mentioned earlier. education is growing through some of those channels, and in turn, we are also then seeing year-over-year growth in the public sector bids and projects, and that's not an accident. You know, the engagement of utilities and other public sector players in some of these more educational or collaborative forums has given them a mechanism for learning more about what smart water can do and how it can be a benefit. And in turn, you know, some of these players are investing in putting smart water networks into place. And we are also seeing, with our own analysis, year-over-year increase in the number of buyers, new buyers each year, but also once there is a purchase made by one of these buyers, we're seeing them come back for more. So that's our update for all of you about smart water. What is it and why now? And I really like to thank all of you for listening, and turn it back to you, Emily.
Thank you so much for that extremely informative presentation, Ebie. If you've enjoyed what you learned here today, be sure to follow us on all your social channels and check out when our next webinar series will be available. Thanks so much and have a great day.